Oh, hello there. Today I will be teaching you how to solve for these two special right triangles, 45, 45, 90 and 30, 60, 90. Okay, let's get started with the 45, 45, 90. Okay, just looking at this may look a little confusing. X's, square roots, yeah. But it may be simpler if we make it into equations. So this is leg 1. So this is leg 1. This is leg 2. Okay, so we can say that leg 1 will always equal leg 2. This is a true statement for any 45, 45, 90 triangle. We can do the same thing for the hypotenuse. The hypotenuse, the longest side, will always equal L1, this, times square root 2. Okay, let's go to the 30, 60, 90. We can do the same thing. L1, L1 will always, okay, so L2, this is L2, will always equal L1 times square root 3. In any 30, 60, 90 triangle, this will always be the answer. And we can do the same for the hypotenuse. The hypotenuse will always equal L1 times 2. So no matter what that is, the hypotenuse will always be this length times 2, and the leg 2 will always be leg 1 times square root 3. Okay, knowing this, let's put some numbers in there. Okay. Long. Yeah, okay. So, let's say this is 5. Based on what I just said, this will also be 5, because leg 1, leg 2, they will always be the same. And the hypotenuse will be square root 5 square root 2. Let's go to 30, 60, 90. Let's say this is 7. If that is 7, then this, the hypotenuse, must be 14, because it is L1, leg 1, times 2. Knowing this, we could use Pythagorean theorem, but it would be much easier if we just knew that the longest leg will always be leg 1 times square root 3. And that would pretty much be solving for that triangle. Okay. Let's make it a little more challenging. Okay, so let's go to the next question. Okay, let's say this is 6. Oh, and to help you guys out, I wrote the equation right there. Okay, so say this is 6. If you remember, or you can just look up there, the hypotenuse in a 45, 45, 90 triangle usually has a square root 2. Or that's what we're used to. But this doesn't. So let's step back, and so the hypotenuse, is just L1 x times square root 2. So if there's no square root 2, then we can just do the opposite of multiplication, which is division. So it will look like this: 6 divided by square root 2. Now that doesn't look right. It's kind of ugly. I think we can make it look a little better. Okay, so if we multiply it by 1, then we can accomplish this. Okay. Now you may be saying, that doesn't look like 1. What is that? It's square root 2 divided by square root 2. Well, if you remember, anything divided by itself equals 1. So no matter what you have as the denominator or the numerator, it will always, like, if they're the same, it will always be 1. So let's go through this. Just off the bat, we can see that 6 times square root 2 is 6 square root 2. And then that square root 2 times square root 2. Well, if like, it's basically just square root 4. So 6 square root 2 divided by square root 4. But I still don't think that looks right. I think we can make it look a little nicer. So if we simplify this, it equals, the square root of 4 is 2. And an easier way we can do this is we can just memorize that if you're multiplying the same number, like square root, if you're multiplying the same square root, then they equal that number. The square roots pretty much cancel out. So this could be square root 20 million times square root 20 million, and you'll just get 20 million. Okay. Although this looks a lot better than what we started off at, we can still simplify. So, in order to get rid of the denominator, we can simplify to 3 square root 2. And the reason is not 3 square root 1. That would be if we divided the square root 2 by 2. The reason we don't do that is because having a square root is pretty much like having an exponent. You cannot multiply a whole number times an exponent. You cannot multiply or divide an exponent by a whole number. Okay, so knowing this, we would know that this L1 equals 3 square root 2, and so does L2. Okay, let's go to the 30, 60, 90. Okay. Let's say that this is 21. Let me just get rid of that. Ever. Say this is 21. If we remember, this would supposedly have square root 3, square root 3 on the end of this. But it doesn't, so we have to do the opposite of multiplication to get 21 divided by square root 3. And we can basically just do the same exact thing. Multiply it by 1, square root 3, divided by square root 3, and get 21 square root 3 divided by 3. But we can still simplify. So let's just put it right here. 21 divided by 3 is 7. So we will end up with no denominator and just 7 square root 3. Having this, we can input that right there. And with this we have to multiply by 2. So, like I said earlier, you cannot multiply a whole number, such as 2, times a square root. So, it will just be 14 square root 3. And that that is how you would solve for the special right triangles. Thank you for watching.